Okay, we're going to take a look at solving quadratic equations. I know it's more fun than you guys should be willing to have, but I'm sure you'll bear with it. Now, the one catch to this whole thing is at the bottom. If A and B are real numbers, and if A times B is equal to 0, then either A is 0 or B is 0. That does sound kind of obvious, doesn't it? That if you're multiplying two things together and they equal 0, well, one of them has to be 0. But what we're going to do is use this idea in order to find the places where the zeros are when it comes to a quadratic formula, or quadratic equation, I should say. And these zeros are the numbers we're looking for. They can be our solutions. So here we go. I want to find the zeros of each of these quadratic functions. So when we start off with something like this, what we are going to do is rewrite it as 4x squared minus 25 is equal to 0. I want to know when that's going to happen. Now, you guys remember all the factoring that we've done? This gets used here. So 4 is a perfect square, x squared is a perfect square, 25 is a perfect square. So what this means for us is that this factors out to be 2x plus 5 and 2x minus 5 is equal to 0. Just rewrite it. Now, once we get it to this point, well, we have two things being multiplied together, right? You can think of this here as our A and this is our B. Okay, so A times B has to be equal to 0. So what we assume is that 2x plus 5 is equal to 0 and 2x minus 5 is equal to 0. Now we just do the algebra. Subtract 5, subtract 5. 2x is equal to negative 5. Divide by 2, divide by 2. X is equal to negative 5 over 2. Add 5, add 5. We have 2x is equal to 5 over 2. Divide both sides by 2. So x is equal to 5 over 2. What this means is that if we go and put in negative 5 over 2, we get 0. If I put in 5 over 2, I get 0. Now, we've been playing with the graphing calculator for some time, and we can use it to go and help us out here a little bit and verify whether or not we've gotten things correct. So I'm going to go put my equation in. That's just going to be the 4x squared minus 25. And I'm going to tell it to graph. It goes down, comes back up. Now you'll notice that it goes across the x-axis. And remember that when it's at the x-axis, the value of y is 0. Can I hit a trace? What happens if I put in 5 divided by 2? What will I get? 0. What happens if I put in negative 5 divided by 2? 0. So what we are doing here again is got a quadratic, factor the quadratic, set it equal to 0, and solve each one. Let's try this again. Let's deal with this one. Now when I look at 2x squared plus x is equal to 0, I don't have three terms, so I can't factor it out that way. Although there's an x in each term, so could I factor it as follows? X times 2x plus 1 is equal to 0. Would that make sense to factor it out like that? Is that what you would expect to see? If yes, a little head nod helps. If no, let me know, and then we can talk about this a little bit more. But now we have two things. I have x multiplied by what's in the parentheses. So in order for this to be equal to 0, either one of two things must happen. Either x is equal to 0, or 2x minus 1 or plus 1 is equal to 0. Now I can solve this for x, subtract 1, subtract 1. 2x is equal to negative 1, divide by 2, divide by 2. So I have x is equal to negative 1/2. So what does this look like? Can I graph this thing? Well, I sincerely hope I can. So let's see. Let's get this thing out again. Over here. So if I put in 2x squared plus x in graph, does it look like it hits the x-axis? Does it look like it touches? Sort of, kind of. If I hit trace, notice how this says if x is 0, y is 0. Well, isn't that what we've seen down here? If x was 0, y is going to be 0. So the next one should be at negative half, right? So we're in the trace, and if I go negative 1 divided by 2, I get another 0. So these are the zeros of the equation. These are the solutions. These are the things that we look for. And right now I realize we're not quite to that point yet where we can apply it. But is there any questions on how to go through and do the algebra right now? Something specifically that you see that you want me to go over some more? Okay. Now, there is also another word that gets used called roots. So there are three words that essentially mean the same thing for us. Solutions, zeros, roots. Each one gets used in its own way, but they essentially mean the same thing. So I want to go through and solve this. I want to know where its roots are. I want to know where the zeros are. Now we've seen equations like this before. Let's get it set up so that we can work our factoring on it. So we would have then x squared plus 2x minus 15 is equal to 0. Does that make sense to everybody? Remember, we just added 2x to both sides, subtracted 15. So now, for those of you that aren't paying attention, can I factor this out nicely? In other words, are there factors of 15 that have a difference of 2? Will 3 and 5 have a difference of 2? So remember, parenthesis, parenthesis equals 0. This is negative, so that means one of these has to be positive, the other one needs to be negative. We have an x here, we have an x here. So I want a positive 2, so that means that 5, the larger one, must be positive, and 3 must be negative. So do I have it factored like I should? Yes or no? If you do the FOIL to it, does it work back out again? Always check. X times x, x squared. X times negative 3 is minus 3x. 5 times x is plus 5x. 5 times negative 3 is negative 15. Like terms come together for 2x. So I get x squared minus 2x, or correction, sorry, plus 2x minus 15. So did it factor out correctly? We've been doing this for a while now. Does it track? So now that we've gotten this part, we've been factoring for a while now. As I said, we're going to go and figure out where the roots are. So that means that I am going to take either x plus 5 equal to 0, or x minus 3 is equal to 0. Those are the two possibilities. Subtract 5, subtract 5. X is equal to negative 5. Add 3, add 3. X is equal to 3. So I'm going to graph this again and see if this actually works out. So I graph the equation. So I've got x squared plus 2x minus 15. Graph. Okay? So I can graph the equation. Gives me all the possible values that are there depending upon what x is. I want to know where this is 0. Does it go across the x-axis? Yes. If it goes across the x-axis, y is 0. So, trace, let's put in negative 5. Negative 5. It's a 0. It works. If I go through and put in, if I go and put in the 3, I also get 0. So the process that we have here, factor the quadratic, set it equal to 0, take each of the factors, set them equal to 0, and solve. So, questions on this one? Time for another one? Let's see what we get. Now, this piece of information here is something that you should have written down in your little book. Okay? If we have a graph of a parabola and it does not hit the x-axis, there are no real zeros. That's just one of the things with it. No real zeros. You also will find it rather interesting when you factor it out. If it touches at its vertex, there is one real zero. There will be one solution. You will only have one number. If you have your quadratic equation or quadratic formula equation plugged in, graphs it out, and it goes across the x-axis in 2 spots. Now we have 2 real zeros. If we take a look at what I had here on the graphing calculator, it crossed here, crossed here. So I'm going to give you a few more moments to make sure that you got that. All right, so here we go. Now, my first question is, does this have a solution? If I look at this, I see that x-axis and it hits right down here. So it does appear that it would have a solution. So it appears that it's only going to have how many solutions? One. So let's factor. We got this, and this equals 0. We know this is x, we know this is x. That's positive, so we know, and that's negative, so it's going to be a minus and a minus. So what factors of 9 add up to 6? 3. So this would have to be a 3, and this would have to be a 3. Now, do I have two different things there? Well, yes, I have two different things being multiplied together, but are they the same? So do I really just have to concern myself with x minus 3 is equal to 0? Add 3, x is equal to 3. Now, what number is right there? Is that 3? Okay. So, when we find the roots, these are telling us where it hits the x-axis. These are the solutions. These are the zeros. These are the x-intercepts. They all mean the same thing. They're all asking the same questions. I know. Why can't they just have one? It depends upon what we're looking for. That's why we have different terms for it. So, let's try this one. Okay. How many should this one have? Should it have 1, 2, or 0? 2. Okay. So, I got this, so I factor. Well, I look at this, it doesn't have 3 terms, so I can't go and factor it out. Other than factoring out, can I take out a 3? Is that in common? And an x? So if I take out 3x, I am left with an x plus 2 is equal to 0. We agree with that? Like I said, always double check. 3x times x, 3x squared. 3x times 2, 6x. So that means 3x is equal to 0, or x plus 2 is equal to 0. Divide by 3, divide by 3, x is equal to 0. Well, is that right there? That's 0, 0. Okay. Subtract 2, x is equal to negative 2. Is that right there? There you go. This is what we're looking at. This is what we're doing. So, what happens if we have to go the other way? Well, I'm going to kind of keep going back and forth between this page and the last one. If I look at this, x was equal to 0 and x was equal to negative 2. So that means for this one, I am going to have x is equal to negative 5/3 and x is equal to 1. We'll start there. Now, if I go and look at these two, these are whole numbers. Really, that doesn't help me much. Back up, that was a whole number. I back up and I back up and I see whole numbers and whole numbers. Ooh, here's fractions. So x is equal to a fraction here. What did I do to get to that fraction? Well, I divided by 2. So what could I do to both sides to get rid of the fraction? Multiply by 2. Undo what was done. We divided by 2 to get to this. We go backwards, we multiply. So that means that I'm going to multiply both sides here by 3. So now I end up having 3x is equal to negative 5. Now these things were supposed to be equal to 0, right? If I go back to make it equal 0, well, that was subtract 2, or however that worked. I subtracted 2. So if I got negative 5 here, that means I add 5. Add 5. Just like we would usually do to move it to the other side of the equation. So now I have 3x plus 5 is equal to 0. Over here, let's make that equal to 0. All I got to do is subtract 1. Subtract 1. So now I have x is equal to, x minus 1 is equal to 0. Now, they're equal to 0. What did we do to make them equal 0 up here before? I'm going to back up to this one here. X minus 3 is equal to 0. The x minus 3 was in parentheses. That's how I got there. So, even here, the x plus 2. X plus 2 is equal to 0. It was in parentheses. So guess what I put around these things? Could it be parentheses? So would I go 3x plus 5, parentheses, x minus 1 is equal to 0. We're getting closer. Now we are supposed to go and write the quadratic function that has these zeros. So in other words, I start with the zeros, solve them, set them equal to 0, then put them in parentheses, and last but not least, I FOIL things out. So 3x times this is going to give me 3x squared. Times that, negative 3x. Times that, plus 5x. Times that, minus 5 is equal to 0. So, here we go. 3x squared plus 2x minus 5 is equal to 0. Now, if I were to go and use my graphing calculator and put that equation in of 3x squared plus 2x minus 5 and graph it, I see a graph. How many places does this thing go across the x-axis? 2, right? Where were the zeros supposed to be according to what they gave us to begin with? Well, the zeros were supposed to be at negative 5/3. Trace. Negative 5 divided by 3. 0. And at 1, 1. 0. So this is how we go back and forth between the graph, the roots, solutions, equations. Now, take a look at an application. The height of a free-falling object is given by the function. So we got that identified there. Where h sub 0 is the initial height, v sub 0 is the initial velocity in feet per second, h sub t is the height in feet at time t seconds. How long does it take for an object to hit the ground after it is thrown straight down at a speed of 20 feet per second from a height of 84 feet? So, create the equation. h of t is equal to negative 16 t squared. By the way, remember these are lovely little things for ACT tests, MCAs. Plus v sub 0. What's the initial velocity? How fast is it going to begin with? Well, isn't feet per second a speed? So this would be 20t. What was the initial height? 84. So, got the equation. Now, quite honestly, to go through and try and factor this out, won't even try it. I'd use the quadratic formula if I really needed to. But in all honesty, graphing calculator. This is where it really comes in handy. So I know it's negative 16 variable squared plus 20x plus 84. Window. Okay. Now we got to sit here and think about what is it we're talking about? Well, t is in time. Do we care what happened 10 seconds before this? And the answer is no. So where should our time start? Start at 0. If you were 84 feet up, 10 seconds would seem like an eternity if you're dropping something. But we're just going to leave it there at 10. We can always adjust later. Why? Well, that's negative 10, and I'm going to leave it. And the reason why, I get better definition, resolution, I can see it better where the graph crosses the x-axis. What should my height be, though? Well, how tall is the building? 84 feet, so I'm going to put it up at 90. So when I graph, boom. Now, I can tell you already that this was not thrown straight down because it gained height from when it was thrown. Went up a little bit. But, okay, how long did it take to hit the ground? Now, mind you, this is not distance from the building. This is how long it was traveling and what its height was. So, my question for you is, would this indicate where it hit the ground? If y represents our height, the answer is yes. So if I look at this, it looks like it took it how many seconds to hit the ground? Looks like 3, so let's test that out. Trace 3, enter. There it is, 0. So, and this is what I mean by giving myself a little bit of room to look at here. I can see where it intersects a lot better. So, what I want you to do is I'm going to give you a minute or so here, and I want you to go through and do A. Solve for 0. Find the 0. So, first one. We've got 25 x squared minus 1 is equal to 0. Set it equal to 0 to begin with. Factor. 25 is a perfect square, x squared is a perfect square, 1 is a perfect square. So, these are perfect squares and it's subtraction, so this is a difference of 2 squares. So that'll mean 5x plus 1 5x minus 1 is equal to 0. So that means 5x plus 1 is equal to 0. 5x minus 1 is equal to 0. Subtract 1, subtract 1. 5x is equal to negative 1. Divide by 5, divide by 5. So we have 1 that is going to be at negative 1/5. Now, after you've been doing these for a while, you're going to start seeing the shortcuts. You are going to start seeing what it is. And what I mean by that right now is, okay, 5x and a 1, 5x and a 1. That was positive, that was minus. Well, gee whiz, should this one end up being 1/5? Would you expect that? Add 1, 5x is equal to 1, divide by 5, you get x is equal to 1/5. But you will begin seeing how these work out. So, give you another few moments and I want you to do B. Okay, so for C, when I'm looking at that, I've got the x squared minus 7x equals 0. Do I have anything in common? I got the x, so that leaves you with x minus 7 is equal to 0. So when you see this pattern, when you see an x squared and x, factor that x out. This thing is always going to be x is equal to 0 when it's by its lonesome. And then I got x minus 7 is equal to 0. Well, that's easy. X has to be equal to 7. So, do C. Now, find the roots. We've got 3x squared minus x is equal to 2. Set it up for the zeros. 3x squared minus x minus 2 is equal to 0. Now, is this one going to be an ugly factor? Possibly. We know we got the parentheses. We know it's going to be equal to 0. I know I have to have a 3, and I am going to need that 2. But if I've got my x here and an x here, that's great. That'll get me to 3x squared. But when I multiply over here, that would give me, something else. I can't have that 2 here. This has to be a 1. Now, I need to have this to be a negative 3, so that means the negative goes here. This here is going to be a plus 2. So, this one just comes from working it out. So, if you're in tune to this, that means that x is equal to 1. That would be a 0 there, correct? Would the other 0 be at x is equal to negative 2 over 3? Subtract the 2 to both sides, divide by 3. Now, I'm going to show you something here. Whoops, that is not what I wanted it to do. Okay. Watch this. X is equal to, second plus 7, 1, 2, 3, 7. There we go. I'm going to do something here. We want to know when this is equal to that. So I'm going to put 3x squared minus x and 2. Graph. I see the parabola. I see that the line goes through it. Do they intersect? Yes. Is there a place where 3x squared minus x is equal to 2? Yes, because they're in the same place. They intersect. Now, if I go and hit trace, and I'm on the parabola, and I put in 1, look what I get. 2. Is that what I was wondering? If I put in negative 2/3, I get 2 again.
If the following students can please see Mrs. Lund at this time.
All right, so we were looking for where this was equal to 2. The 1 made it equal to 2, the negative 2 over 3 made it equal to 2. Assignments due, end of class tomorrow.